Okay, you can see we're now getting serious. Science of Santa. The question, is Santa compatible with the laws of physics? Or, to put it in a somewhat more succinct way, just how many laws of physics does Santa break? So, to remind you, I can't believe anybody doesn't know who Santa is, but Santa is, at least allegedly, a portly, jolly fellow with a white beard and a penchant for wearing red suits. So although he does clearly display questionable fashion sense, that doesn't mean he doesn't exist. What about the claims that are made about this gentleman? It is said, allegedly, he visits all households on Christmas Eve to deliver presents to qualifying children. What do we mean by qualifying? Well, that, of course, depends on whether you're on the naughty list or the nice list. Can we reconcile that statement at the top there with our knowledge and our understanding of science? And when I was asked this question by nieces and nephews, I thought, well, I don't want to lie to them, so what can I say about the existence of Santa? I decided to borrow from other talks I've given. I've given lots of talks on different subjects about how the universe works, and I thought I should be able to borrow some of the science we already know about and actually use that to answer this question. So what we're going to do is look at that statement, Santa visits households on Christmas Eve to deliver presents to children, and we're going to scientifically unpick it one bit at a time. Firstly, let's just make sure we know how many children we're talking about. How many? Well, the Earth's population is about 8 billion or so, give or take, obviously climbing all the time. About a quarter of the Earth's population are children, and 50%, let's say, are eligible for Christmas presents. So about 1 billion children in total. I'm assuming Santa is fairly generous and will deliver presents even to children who aren't necessarily in Christian households. And what about that ratio of naughty-nice? Well, let's assume it's 0% on the naughty list and everybody's on the nice list. Any parents in the audience might argue with that particular ratio, but let's just stick with that because it makes the numbers easier. So 1 billion children is what we're talking about. So Santa visits households. How does he visit? How does he get around? What's his mode of transport? Well, it's of course a sleigh pulled by flying reindeer. So can reindeer fly? Well, we know that insects fly and birds fly and pterosaurs fly, even though there aren't many these days. And we know some mammals fly. So the question is, what about reindeer? Well, if they can fly, they apparently choose to do so when we're not around. They don't spend much of their time flying, and when they do fly, no one's around with a camera to actually record it. There is very little evidence for flying reindeer, but remember, science works on evidence, and the absence of evidence is not the same as evidence of absence. That is a key mantra you must remember. Just because we don't have any evidence of them flying doesn't mean they can't. So the jury is still out on that one. We don't know whether reindeer fly or not. Okay, how fast would Santa have to go in order to visit 1 billion children? Well, if you assume that these billion children are spread around the world, he would have to fly at least 2,000 kilometers per second, or about 0.007 times the speed of light, which of course is nowhere near breaking any physics laws. We know from the series of talks I give called Fiat Lux, i.e. let there be light, we know that the speed limit of the universe is the speed of light, and Santa doesn't even get to break 1% of that, so he's nowhere near breaking the speed limit. No object can travel through space faster than light can travel through a vacuum. Space itself is expanding because we live in an expanding universe, and so some galaxies are indeed receding from us faster than the speed of light because the universe can expand basically as fast as it wants to. But moving through space is different, and there we have a speed limit. But at 1%, no problem whatsoever. But if you are moving really fast through the atmosphere, wouldn't the sleigh heat up, and wouldn't we end up with roast reindeer because of the heat generated? If we think of a meteor or an asteroid coming into the Earth's atmosphere, it compresses the air in front of it, and that air then heats up. So again, in a separate talk about how stars work, stars are born by taking a large cloud of gas and compressing it, and it's the act of compressing the gas that heats it up and ultimately ignites the star in the first place. And for anybody that's pumping up a bicycle tire, you know that if you compress air, the air gets hotter. So wouldn't that mean the sleigh gets really hot? Even if it was aerodynamic, wouldn't the sleigh get really hot moving at these incredible speeds? Surely, if compression produces heat and hot things glow, either in the ultraviolet or the visible or the infrared, cool things will glow in the infrared. When they get hotter, they will glow in the visible. And if they get really hot, they'll also produce some ultraviolet light as well. So surely the sleigh ought to be easily visible if it's moving that fast through the Earth's atmosphere. Well, maybe it was visible. I think that's pushing it a bit to say that Santa is responsible for the Star of Bethlehem, as the timing is all wrong. But you could say, well, do we ever see points of light in the sky that are inexplicable? Well, of course we do. That's a whole area of ufology, if you like. Unidentified flying objects are all about people who've seen lights in the sky. But we don't have to worry about hot objects glowing. If we think about it, there is a type of matter which doesn't glow. What type of matter do we know about that even if you get it hot, i.e. get it very energetic, it still doesn't glow? Virtually everything we know about in the world around us, when you heat it up, it glows. But we know that there's some parts of the universe that don't obey that particular rule. Dark matter. We know there's more dark matter out there than there is ordinary matter. We know there's huge amounts of it. There's probably 85% of all the matter in the universe is dark matter. We don't know what it is, but we know it doesn't emit light and it doesn't absorb light and it doesn't reflect light. So maybe that's an explanation for why, even though the sleigh moves really fast through the Earth's atmosphere, it doesn't glow. And also, if it doesn't emit light or absorb light or reflect light, then the sleigh won't reflect radar either, so it doesn't show up on any radar scans. So maybe that's an explanation. Santa and his sleigh, and presumably the reindeer as well, are made of dark matter rather than ordinary matter. Doesn't break any laws of physics as we understand them. Okay, Santa visits households. How can Santa get down so many chimneys? Remember, Santa is a rather portly fellow, and a chimney is usually only a few centimeters in diameter, so how could Santa possibly squeeze down so many chimneys per second? Well, if we resort to our understanding of quantum theory, which tells us about people are made of molecules, molecules are made of atoms, atoms are basically a nucleus surrounded by a whole load of electrons buzzing around. The size of an atom and the size of a molecule is dictated by the fact that the things that are buzzing around the nucleus are electrons. But what if Santa could replace those electrons with muons? Muons are the heavier cousins of electrons. They have the same charge and many of the same properties, but they are 200 times heavier. And when you make an atom with muons, your atoms end up 200 times smaller. So if somehow Santa could replace his electrons with muons, I don't know how he would do that, but if he could do that, he would then be 200 times smaller. So instead of being a gentleman between 1.5 and 2 meters tall, he would only be a centimeter or so high. And he would fit down a chimney, no problem whatsoever. Again, I don't quite know how he would do that, but if that was the case, he wouldn't be breaking any laws of physics. That doesn't help if there isn't a chimney. What if you're dealing with a domicile, a house, an apartment that doesn't have a chimney? How does Santa get from the outside to the inside if there's no open doors and no open windows? Again, we can resort to quantum mechanics for the answer, because we know that when we look on the quantum scale, when we look at the properties of particles and atoms and molecules, we know that it is possible for an object to go from point A to point B, even if there's an impenetrable barrier between them. We know it happens. We've built microscopes based on that principle. So it's not just an esoteric part of theory. We've actually built devices based on that idea. And so the weird world of the very, very small, the description of quantum theory, tells us that you can so-called tunnel. Quantum tunneling does exist, and we know it is real in the sense that we can build things based on this principle. You can go from outside the room to inside the room, even though there's an impenetrable barrier, such as a door or a window. That doesn't matter. Quantum theory allows an object to pass through. It's not very probable that that happens, but it is not impossible. Therefore, that's okay as far as Santa is concerned. How does Santa do all of this on Christmas Eve? How does he do it all on one night? Even if you're traveling at really high speed, a fraction of the speed of light, remember you haven't just got 12 hours to do this. It's not just nighttime. If you use the time zone sensibly and you work around the clock, as it were, from one time zone to the next, you actually have about 36 hours to play with. So how can Santa do all of that in 36 hours? Well, again, quantum mechanics comes to our rescue because we know from quantum theory that a particle or an atom or a molecule can be in two places at the same time. And Santa, if he's made of molecules, well, why can't Santa be in two places at once? We know when we look at the quantum world, we get all sorts of weird results, like a particle can spin clockwise and anti-clockwise at the same time. Makes no sense to our common sense of how the world works at this scale, but we know that is how the world is when we look at the quantum scale. So not only can objects spin clockwise and anti-clockwise, objects can be in two places at once, and it's not limited to two. Could Santa be not in two places at once? Could he be in 10 places at once? Or 1,000? Or 1,000,000? There's nothing in the laws of physics that says he can't. Therefore, that's allowable. If you don't like the idea of Santa being in more places than one at any given time, there are alternative ways that he can deliver all of these presents. When we look out into the universe, we see that matter distorts space. It basically warps space and it warps time. If Santa has figured out a way of manipulating space and time, then instead of having to visit all of these households, maybe he just distorts space in such a way that all of those households come to him, rather than him having to travel to them. Again, from our understanding of how matter distorts space, we know it happens, we've seen it happen, we can make observations where we see that space is being distorted by matter. Maybe Santa has figured out a way of distorting space to his advantage. Who knows? Okay, so we've said Santa visits households on Christmas Eve, and he delivers presents to children, 1 billion children, so presumably 1 billion presents. This is going to be a bit tricky. One present for each of 1 billion children. How could the sleigh hold that many presents? There's actually more than one way that this could happen. One way is to bear in mind that the sleigh is perhaps a few meters or so in size, so you might think it has a volume of a few tens of cubic meters perhaps, and that doesn't seem enough to have 1 billion presents in it. But bear in mind, the volume on the inside is not necessarily the same as the volume on the outside. We know that there are things out there in the universe that are bigger on the inside than they are on the outside, and I'm not talking about Doctor Who's TARDIS. That's science fiction. But science fact tells us that it is possible to distort space such that for a given object, for a given, let's say, sphere, it can be bigger on the inside than on the outside. Again, maybe Santa is using this to his advantage, such that the volume of the sleigh on the inside is substantially bigger than the volume on the outside. We've seen it happen for black holes. We know that black holes are bigger on the inside than they are on the outside. Maybe, again, Santa has figured out a way of manipulating space and time to use this to his advantage. And if you don't like that explanation, there's another one. How do we know how many dimensions there are? We believe there are 3 dimensions of space, or at least we can perceive 3 dimensions of space and 1 of time. So we've got forward, backward, left, right, up, down. But many scientists believe that that is not necessarily all there is. Maybe there are more than 3 dimensions. Some people believe there are 10 or 11 or more dimensions, and we are just able to perceive 3 of them. Perhaps, if that's the case, Santa has figured out how to access these other dimensions. So all you need to do is to take your presents, push them into the other dimension, in which case they apparently disappear from our 3 dimensions. You then visit your households, and then you pull them out of the nth dimension and put them under the tree. Again, we can't prove that that doesn't happen because we can only perceive those 3 dimensions, but it doesn't mean those other dimensions aren't there. There could be many more than 3. We simply don't know. But you might say, yeah, right, maybe maybe he doesn't break any laws. But in order to do any of these things that I've been mentioning, surely that would need an incredible amount of energy. Wouldn't that need a huge amount of energy? Santa and sleigh and 1 billion presents moving at high speed to all of these destinations? Well, yes, it would. So the question is, where are we going to get all this energy from? Well, again, a black hole could provide the answer, because we know that a black hole in principle could power a starship and send you to the nearest star, not simply to the planets in our solar system. It could send you to the stars. The black hole would not need to be very large. A black hole that's tiny, smaller than a grain of sand, would provide enough power to give you the energy that you need. But we're overlooking something. There's an energy source that we haven't mentioned yet. It's the elephant in the room, and that is, what happens to all the mince pies? There are millions of mince pies that are given to Santa. No one thinks he actually eats them all, surely. So what happens to all of these mince pies? Think about not the mass, but how much energy there is in a mince pie. What if Santa could convert all of the mass of a mince pie into energy? We know what the conversion rate is, E equals mc squared. So if we know the mass of a mince pie, we can work out how much energy Santa would have available. So let's do the maths and figure it out. The mince pie is about 50 grams. So one mince pie, E equals mc squared, 50 grams times the speed of light squared. In SI units, that gives us an energy of 5 times 10 to the power 15 joules. How many mince pies? Not everybody leaves mince pies out for Santa. Let's just assume a few percent leave mince pies out for Santa. Let's take the number as 20 million to make the maths easier. 20 million mince pies gives us 20 million times that number, which gives us a total of 10 to the power 23 joules. And even if you know what a joule is, trying to think how big is 10 to the power 23, one with 23 zeros, that's an awful lot of energy. One way of visualizing it is to remind yourself that a nuclear power station generating, for instance, a gigawatt of power, that's 1 gigajoule per second. Let's imagine a nuclear power station running every second of the day, every day of the year, for 1 million years. That amount of energy is 10 to the 23 joules. So if Santa could use mince pie power, as it were, he would have the same amount of energy as a nuclear power station running for 1 million years. And he would have that energy available during the 36 hours of the night. Okay, how do you extract E equals mc squared from a mince pie? Well, the most efficient way of taking energy out of matter is to collide it with antimatter. And of course, you can do that with the Large Mince Pie Collider at CERN, which would allow you to get all of the energy out. But you can already see the problem. Yeah, where do you get the anti-mince pies from? If you had those, you'd be golden in terms of extracting all the energy you want. So if you've only got matter and not antimatter, what can you do about extracting the energy? There are alternatives. It won't be as efficient. You won't get 100% of the energy out, but you might get 5%, 10%, 20%, maybe more of the energy out of a mince pie if you simply drop it into a black hole. We know that because we've seen it happen. Okay, where do we see that happening? Well, there are things called quasars. A quasar is a galaxy with a supermassive black hole at its core, and matter is falling into that supermassive black hole. Okay, the matter is probably not mince pies. The matter is probably stars falling in, but that process is so efficient that a galaxy that is many, many billions of light years away still is visible because of the efficiency with which matter is converted into energy. During the lockdown in 2020, I imaged a quasar without using a telescope. Just using my camera and pointing it in the right direction, I picked up the light from a quasar that was 25 billion light years away. And it's only possible to do that because the quasar is generating so much energy, because matter falling into the black hole generates huge amounts of energy. That works really well for stars. How effective would it be for mince pies? Strangely enough, I can't find any research on the subject. I've looked, but I can't find any research papers. It appears that very few studies of dropping mince pies into black holes has been carried out, but I'm sure it's as efficient as dropping stars into black holes at the centers of galaxies. So Santa would have no problem with the amount of energy needed to do all of the things that I've been talking about. So he doesn't break any laws. He needs huge amounts of energy, but we know in principle he's got huge amounts of energy. But you still have the question, yeah, but how does he know how to do all of this? How does he know how to use quantum theory? How does he know how to use the distortion of space and time to his advantage? Well, one thing to bear in mind, who says he has to be human? Maybe Santa has got skills that we're not really quite aware of. Remember, no one's actually seen Santa. Children are always asleep when he visits. Therefore, we don't actually know what he looks like, except for the adverts and the Christmas cards. Again, not documentary evidence of what he actually looks like. So coming back to the original question, just how many laws of physics does Santa actually break? I would argue the total number he breaks, none. So feel free to draw your own conclusions about the existence or otherwise of the portly jolly fellow with a white beard and a penchant for wearing red suits. And regardless of the conclusion that you come to, for the second time this evening, I wish you all a very Merry Christmas. Thank you.